We want to factor this completely. First, we look for a greatest common factor. There are none, so we might try grouping. We could try breaking it up with the first terms and the last terms. If we did that, we have a common factor of x in the first term, so we'd have x times x plus 5. But then in the last terms, we don't have any common factors, although we do have the sum and difference of the square roots because we have the difference of squares. But we'll see we have no common factor here, so it doesn't help us because we can't go to the next step in that grouping. So that choice won't work. Another choice we might recognize is how about if instead of splitting in the middle, we group the first three and leave the last term. Because the first three, if we break down this trinomial, what we'll see is perfect squares so that it factors into x plus 5 times x plus 5, leaving the 9y squared. But the only way we'd recognize that that helps is if we write it as x plus 5 quantity squared minus 9y squared, because now we can see we have the difference of two squares. If you recognize that you have the difference of two squares, the square root of the first term is x plus 5, so that's our a. The square root of the second term is 3y, that's our b. So that allows us to factor it into the sum and difference of, we put a first, and then the b, and so we have the sum and difference of the square roots, which gives us x plus 5 plus 3y times x plus 5 minus 3y. Neither of those can be broken down further, so that's the completely factored form.